Hi, good evening to all. Welcome to SV EduTech. I'm happy to conduct this quiz. So once again, welcome to all. Now I'm trying a new quiz like quizzes. Its website name is quizzes, Quizzizz. So it is very interesting game. It is a website where everyone can participate in this. So yes, I'm happy to see that a lot of members are participated. So now I will share you the link so that you can click it and you can join on that. So you just click on this link so that you can participate in this. So please click on the link. Maybe few members have this idea about this. It is very interesting quiz. I am trying to bring new ways to participate to create interest in you. Is my voice audible to you all? Hi, good evening to all. So, if yes, in the sense, please message me. I'm trying a new quiz. So, this is a link that you can participate. So, 59026803. I'm again sharing this. You just click it and join in this. It's a live game. So I think you definitely like it. Yes, I got 5 members joined in this. Bhavita, Arjun, Sneha. So still how many of you can join on this live stream? So again, I'm typing this. It is a link. You just click it so that you can directly join in that. So I hope 6 members join. So it's you can just use this also, joinmyquiz.com, and you can type the code 59026803, or simply you can just click on the link that which I have posted here. Yes, very good evening to all. I'm happy to see each and everyone are participating in this. So just click on the link that which I have posted so that you will be redirected into a new one. So I hope 10 members, 11 members joined in this. So it is a very new website where we can play quiz online and you can see your score. Till now, I'm just conducting the quiz in the YouTube only, and now you can also see how much you have scored, that also. So I hope 12 members joined in this. So I will just share the question on the screen and you can see and you can type it. So now it's 13 members joined. So I just wait for some time also so that I can see more members can participate in this. You can just click on the link and you can type it. So now I'm starting this. So I think you all are ready. Shall we start? Okay. So I hope you all are very excited. So now I'm starting this. Yes. So the question on your screen, refractive index of diamond. So what is the refractive index of diamond? Is it 1.43, 2.41, 1.42, 2.41? So what is the refractive index of diamond? Oh, by mistakenly I have typed it. So yes, you can play it here in the sense. Radius of optical fiber is about, it's 10 power minus 8, 10 power minus 5, 10 power minus 6, 10 power minus 7. Which is the correct answer? So what is the radius of optical fiber? So your answer is 10 power minus 6 meters, ma. And the next question is refractive index of glass slab. Refractive index of glass slab. Refractive index of glass slab. It's thickness of slab by thickness of slab minus vertical shift. So that's his answer. And then coming to the next question. So what is the radius of optical fiber? So the next question is which of the following is Snell's law? N2 by N1 is equal to sin R by sin I, or N2 sin I is equal to constant, N1 by N2 is equal to sin R by sin I, or N1 sin I is equal to sin R by N2. So which is the correct answer for this? So some network issues. So here. So are you playing, ma? I'm not getting any answers. I think you just. So do one thing, please, all of you come out. You just come out of the site, ma. I'm not able to see you also. So just you just. So please, just all of you. 1 minute. Just a minute. I'm opening it. So you can play it. I will send it, but online we can't play this. So please, all of you, just join in YouTube only. So just come to YouTube. So if the angle of incidence is greater than critical angle, then light enters into denser medium. This phenomenon is called. So what we call angle of incidence is greater than critical angle. Then what happens to that? So what is that phenomena called as? So is it reflection, refraction, total internal reflection, or none of the above? So which is the correct answer? If the angle of incidence is greater than critical angle, then light enters into denser medium. So, and this, the correct answer is total internal reflection. So, please, all of you come to YouTube, and I'm just asking you questions. You just type it. So, it will be fun only, but I'm not able to see you. So, that's why I hope you understand. So, please come to online, YouTube only. So, please join in YouTube. So then I will share you the link. You can click and play in it. So now coming to the next question. So this answer is total internal reflection. It's correct, ma. So now coming to the next question. So the next question is the process of bending of light ray except when it is incident at normal. So the process of bending of light ray except when it is incident at normal is called, is it critical angle, refraction, reflection, total internal reflection? So A critical angle, B refraction, C reflection, and D total internal reflection. So the process of bending of light ray except when it is incident at normal is, so it is nothing but refraction. So Yogeshwar Reddy Bhavana, you just typed option 3, correct. Now from this here it is refraction is correct, ma. So maybe due to some network issues, we will be getting delay. So this answer is refraction. So let me see the how many of you type. Yes, it is correct. Now coming to the next question. Refractive index of diamond. So refractive index of diamond is it 2.41, 2.42, 1.42, 1.43. So what is the refractive index of diamond? 2.41, 2.42, 1.42, 1.43. So what is the refractive index of diamond? Refractive index of diamond. So then the answer is 2.42. That is the correct answer. Dash compare refractive indices of two media. Is it relative refractive index, total internal reflection, critical angle, absolute refractive index? So which compare refractive indices of two media? Yes, correct answer. So relative refractive index, relative refractive index of two media means relative refractive index compares refractive indices of two media. And then coming to the next one, so it's 2.42. 2.42 is correct answer. So now coming to this, Nash compare relative indices of two media means it is relative refractive index. Yes. Now the next question is reflection takes place. So when reflection takes place, ma, for all angle of refraction, for all angle of incidence, for critical angle, none of the above. So reflection takes place. So where it takes place? Reflection takes place for all angle of refraction, for all angle of incidence, for critical angle, none of the above. So reflection takes place. So yes, the correct answer is reflection takes place for all angle of incidence. It is the correct answer. So reflection takes place at for all angle of incidence. So అన్ని యాంగిల్ ఆఫ్ ఇన్సిడెన్స్ దగ్గర రిఫ్లెక్షన్ అనేటటువంటిది జరుగుతుంది. వెరీ గుడ్. సో yes, relative refractive index. Now coming to the next. For all angles of incidence is the correct answer. Congratulations. Yes, for all the angle of incidence. This is right answer. Sorry, there is no time for me to just type the answers also. It is somewhat very short time is there. So I think individually we can use this instead of. Now coming to that next question. Angle between incident ray and normal. So what is the angle between incident ray and normal? Is it angle of incidence, angle of refraction, angle of emergence, angle of reflection? So the angle between incident ray and normal. Angle between incident ray and normal. So yes, Harika, Jyotika and Aisha, Reddy, Bhavita all typed correct answer only. Very good. So now just type this answer, angle between incident ray and normal. So what we call this as? So it is angle of incidence. So angle between incident ray and normal is called angle of incidence. This is the right answer for this. Very good. Congratulations for those who answered correctly. So now angle between incident ray and normal ray is called as yes, Jyotika, Sai Lakshmi typed correct. Amruta, Sneha also typed correct. Yes, it is correct only, ma. Very good. Now coming to the next question. Whose name is attached to the refraction of light? So is it Fermat, Newton, Snell, none of the above? Whose name is attached to the refraction of light? So whose name? Is it Fermat, Newton, Snell, none of the above? So maybe some technical issue. I am just somewhat fast instead of your answers. Very good. Those who answered correctly, congratulations for all them. So now whose name is attached to the refraction of light? It's nothing but Snell. So Snell's law. We already told that Snell's law. So during refraction, light follows Snell's law only. So here Snell's name is attached to the refraction of light. Now coming to the next one. Eighth question, units of refractive index. So what are the units of refractive index, ma? Is it kilometer per second, Newton, no unit, or meter per second? So what is the correct answer for this? So those who answered correct for the previous questions, very good, keep it up, congratulations. And now just try to answer this. Yes, it's correct answer. So due to some technical issues, somewhat late the answers I'm getting here. So don't worry for that. So it is correct only. And now units of refractive index is, it has no units. So refractive index has no units. So refractive index has no unit. It is a dimensionless quantity. It is a dimensionless quantity, ma. Okay, right. Now coming to the next question. Congratulations, those who are typing the correct answers. All the best for you for the next questions. During refraction, light follows. So now only I just told you which law is followed during refraction. Is it Snell's law? Is it Newton's law? Is it Fermat's principle? Or all the above? So during refraction, light follows which law? Is it Snell's law, Newton's, Fermat's, all the above? Yes, it's correct. Since no units only. Now here we will take it as Snell's law. So Snell's law is the correct answer. During refraction, light follows Snell's law. Yes, no units for the previous question, and this is Snell's law only. So during refraction, light follows Snell's law. It is the second law of refraction of light. Now coming to the next question. So it is radius of optical fiber. So radius of optical fiber, is it 10 power minus 5, 10 power minus 8, 10 power minus 6, and 10 power minus 7? So what is the radius of optical fiber? So you already know this about optical fiber. Optical fibers are made with glass or plastic with a radius of about dash meters. Is it 10 power minus 5, 10 power minus 8, 10 power minus 6, or 10 power minus 7? So very good. Those who answered for the previous question, it is correct only, Snell's law. Now this question, radius of optical fiber is about dash meter. So yes, the answer is 10 power minus 6 meters. So radius of optical fiber is about 10 power minus 6 meter. Okay, very good. Congratulations, those who are typing the correct answers. So radius of optical fiber is about 10 power minus 6 meters, and optical fiber works with the principle of total internal reflection. Total internal reflection. Now coming to the next question. So those who are answered, so this is for that, ferret out the answer. Now coming to the next. So the distance between incident and emergent parallel rays. What we call the distance between incident and emergent parallel rays. Incident and emergent parallel rays. Incident and emergent parallel rays. Yes, beam, shift, shaft, none of the above. What we call this as? Is it beam? Is it shift? Is it shaft? Is it none of the above? Yes, it is shift. Shift is the right answer. The distance between incident and emergent parallel rays is called as shift. In this, when you place the glass slab horizontally, then you can get lateral shift. When you place the glass slab vertically, then you will be getting a vertical shift. Okay, so the distance between incident and emergent parallel rays is called shift. Now coming to the next question. So this is for you, those who answered with correct. Now coming to the next. Snell's law fails. So where the Snell's law fails? When light is reflected on the surface of a refracting medium, when light is incident normally on the surface of a refracting medium, when light is emerged on the surface of a refracting medium, none of the above. So this Snell's law fails. Where the Snell's law failed? Is it reflected, incident, emerged? So now it's incident. It is a right answer. Snell's law fails when light is incident normally on the surface of a refracting medium, because normal means whenever light falls on normal, it does not deviate, it just goes straightly. So when light is incident normally, there Snell's law fails. Okay, so this is a right answer. And those who answered it correctly for this, brilliant, it's not brilliant, it's brilliant. Very good, keep it up. Now coming to the next question. Mirage is an example of, definitely you will write it correct option, you will choose the correct option. Is it reflection, refraction, critical angle, or total internal reflection? So mirage is an example of, means, so we already know this, where you can see water fallen on the road, but when we go there, you can't find the water. So it is called as mirage. It will be seen in normal roads when we are traveling. Yes, mirage is an example of total internal reflection. It's total internal reflection. Yes, those who answered it correctly, very good, congratulations. So some network issue is there, sorry for that. Yes, B is correct. So now this next question. At a certain angle of incidence, the refracted ray does not comes out but grazes the interface separating air and glass. Measure the angle of incidence for to this situation. This angle of incidence is known as. So what we call this as? Yes, option D is correct, ma. Very good for the previous one. Now this one, is it total internal reflection or critical angle or refraction or none of the above? Yes, it's nothing but critical angle. So there's the angle of incidence where is at certain angle of incidence, the refracted ray does not enter into rarer medium, but it grazes between the two media. Okay, so that is nothing but critical angle only. And Those who answered for the previous question, it is very good. Congratulations, that is the correct option. Now it is critical angle. Option B is right, critical angle. So B is correct. Now coming to the next one. So just those who are typing it correctly, this is for you. It's a gift for me. You are quite the investigator. So now coming to the next one. Yes, Harshavardhan, Sneha, Reddy Bhavana, Jyotika, Aisha are typing. So no, it's option B, ma. B is correct. Okay, now coming to the next question. Yes, with all your answers, I just stood in the first place with 10,880 points. This all credit goes to you only. Now coming to this next question. So 15th one. Twinkling of stars is due to. So twinkling of stars, is it due to reflection? Is it due to refraction? Is it due to total internal reflection or critical angle? So which is the reason for the twinkling of stars? We see night times twinkling of stars. That is due to, is it for reflection, refraction, total internal reflection or critical angle? So twinkling of stars, twinkle, twinkle, little star, how I wonder what you are, like this. So what is the reason for that? So yes, it's right. Your option, your guess is right. It's refraction only. So twinkling of stars is due to refraction. So this is the correct answer. So due to atmospheric refraction, stars will be twinkling because there is a difference in the speed of light because there is change in medium. Therefore, medium, when there is a change in medium, definitely speed changes. As a result, direction changes. That is nothing but called as refraction. So now it's option B is correct. Very good. So let us see where we just went halfway done. So we completed half of the questions. That means out of 30, we just answered 15 questions. So halfway done. Yes, very good. With your support and interest, we just completed halfway. Let's go to the next half. Yes, your option B is correct only. Coming to the next. So just we stood with 11,780 points. And now coming to the next question, that's refractive index of glass is 3 by 2. So they given n value. Then the speed of light in glass is 2 by 3. So they have given the speed of light also 2 by 3 of is, and then light in glass is 2 by 3 of 3 into 10 to the power of 8 meter per second. So speed of light they given, refractive index of glass they have given. We need to find the speed of light in glass. So what is that? Is it 2 into 10 to the power of 10 meter per second, 3 into 10 to the power of 10 meter per second, 2 into 10 to the power of 8 meter per second, or 3 into 10 to the power of 8 meter per second? So what is the correct answer? Yes, your guess is correct. 2 into 10 to the power of 8 meter per second. So it's 2 into 10 to the power of 8 meter per second. So sorry, some network issues are there. Due to that, I'm not getting properly. So option B is correct only, I told that. Now, refractive index depends on. So, refractive index depends on wavelength, frequency, nature of the material, A and C. So, this is correct. Now refractive index depends on wavelength, frequency, nature of the material, or A and C. Refractive index depends on, yes, its refractive index depends on, yes, that is right answer. And here also for this refractive index depends on option A and C. Yes. The refractive index depends on nature of the material and as well as wavelength, both. So yes, for this, up to this, you are typing very correct answers. Now coming to the next question. Refractive index depends on, is it wavelength, frequency, nature of the material, means both A and C. So it's option D is correct, ma. Yes, now coming to the next. Which of the following is Snell's law? So which is a Snell's law? Is it N2 sin I is equal to constant, N1 sin I is equal to sin R by N2, N1 by N2 is equal to sin R by sin I, N2 by N1 is equal to sin R by sin I. So which of the following is Snell's law? N2 sin I is equal to constant, N1 sin I is equal to sin R by N2, N1 by N2 is equal to sin R by sin I. Yes, it's correct. Those who typed it is congratulations for them all. Now answer this. So for this it is N1 sin I by N2 sin R is equal to, so make half the incorrect options disappears. So Snell's law, N1 by N2 is equal to sin R by sin I. So this you can also write as N1 sin I is equal to N2 sin R also. That also you can write like that. So this they have given N1 by N2 is equal to sin R by sin I. So now coming to the next one. The angle of deviation produced by the glass slab, is it 20 degrees, 90 degrees, 0 degrees, or depends upon the angle formed by the light ray and normal to the slab? Sorry, I'm a bit fast because due to the network it is not stopping. This is the time kept by me for this is very short time, so that's why, don't worry. So angle of deviation produced by the glass slab, is it 20 degrees, 90 degrees, 0 degrees, or depends on the angle formed by the light ray? Yes, your option is right. Depends on the angle formed by the light ray and normal to the slab. So always the angle of deviation depends upon the angle formed by light ray and normal only. Okay, very good. Those who answered it, very good. Keep it up. Now coming to the next one. So a test tube is immersed at certain angle in a tumbler of water. To have a mirror surface for certain viewing position, it is due to. So if a test tube is immersed at a certain angle in a tumbler of water, to have a mirror surface for certain viewing position, అంటే ఒక పర్టికులర్ పొజిషన్ లో మనకి మిర్రర్ లాగా సర్ఫేస్ కనిపిస్తుంది. అలా ఉన్నప్పుడు ఇన్వర్ట్ చేస్తే అది దేని వల్ల మనకి ఎలా కనిపిస్తుంది? సో ఇస్ ఇట్ రిఫ్లెక్షనా, టోటల్ ఇంటర్నల్ రిఫ్లెక్షనా, రిఫ్రాక్షనా, స్కాటరింగా? So yes, Please correction for this. It is nothing but total internal reflection. So that is due to total internal reflection. So a test tube is immersed at a certain angle in a tumbler of water to have a mirror surface for certain viewing position, because total internal reflection will be taking place if the angle of incidence is greater than critical angle. It reflects into the same medium only, denser medium reflect అవుతుంది. Okay, now coming to the next one. So the critical angle of diamond. So what is the critical angle of diamond? Is it 23.4 degrees, 24.4 degrees, 21.4 degrees, and 22.4 degrees? What is the critical angle of diamond? Yes, I hope all are typing correct answers only. So critical angle of diamond, is it 23.4 or 24.4 or 21.4 or 22.4? So what is the correct answer? So yes, it's 24.4 degrees. So the critical angle of diamond is 24.4 degrees. Yes, one more power we have taken. With this, now going to the next question. Speed of light in vacuum. So definitely you will type this. So it is nothing but is it 3 into 10 power 10 meter per second, or 3 into 10 to the power of 8 meter per second, or 2 into 10 to the power of 10, or 2 into 10 to the power of 8? So what is the speed of light in vacuum? The speed of light in vacuum, is it 3 into 10 to the power of 10, or 3 into 10 to the power of 8, 2 into 10 to the power of 10, 2 into 10 to the power of 8? So yes, it's right. Yes, 3 into 10 to the power of 8 meter per second. It is the right answer, ma'am. So yes, those who are typing correct answers, very good. Congratulations, keep it up. Now here the speed of light in vacuum is 3 into 10 to the power of 8 meter per second only. Now coming to this next question. So you are just praying for the right answer. The next one, refractive index of glass slab. So what is the refractive index of glass slab, ma'am? So is it refractive index of glass slab is thickness of slab by thickness of slab minus vertical shape, thickness of slab by vertical shape, thickness of slab by thickness of slab minus lateral shift, thickness of slab by lateral shift? Which is the correct answer for here? Thickness of slab by thickness of slab minus vertical shift. So thickness of slab by vertical shift. Yes, this is the right answer. Thickness of slab by thickness of slab minus vertical shift. So it is the correct answer to find the refractive index of a glass slab. So now coming to the next one. So with your answers, I am there at top position with 18,980 points. Very good. Thanks for your support. Yes, now just going with next question. Okay, we will use this power up also. Total internal reflection takes place when a light ray propagates from dash to dash medium. So when total internal reflection takes place? So for this, rarer to denser, or denser to denser, or denser to rarer, or rarer to rarer? So total internal reflection takes place. So when total internal reflection takes place, ma? Rarer to denser, denser to denser, denser to rarer, or rarer to rarer? Yes, your guess is correct. That is denser to rarer. So total internal reflection takes place when light is traveling from denser medium to rarer medium only. But it reflects into rarer medium, denser medium only. But total internal reflection will be taking place whenever the light is passing from denser to rarer only. Okay, so this is the correct answer. Very good. So congratulations, those who are typing correct answers. So let us see what is our score. So it's 19,880 points. Congratulations for all of us because we all together are getting the score. Yes, now coming to the next question. It's 24 completed, 25th one. Yes. A coin placed in water appear raised. Why? Why a coin placed in water appears raised? Due to refraction, due to total internal reflection, or due to reflection, or due to critical angle? Yes. Bhavana, Harika, Sneha, Bhavita, Vanisri, very good. Jyotika, Aisha, very good for your answers. Keep going. So why a coin placed in water appears raised? Is it due to refraction or due to total internal reflection or due to reflection or due to critical angle? Yes, it's due to refraction. It is the correct answer. Very good. Keep it up. So due to refraction only, the coin placed in water appears raised. Very good. Congratulations. Keep it up. So is correct answer. Congratulations, those who typed it. Now coming to the next question. So with this, I just entered into 20,000 club. That is 20,780 points. Very good. Congratulations. With all your correct answers, we just in this position. Let's see that angle between normal and emergent ray. So what we call this as angle between normal and emergent ray? Is it angle of refraction, angle of emergence, angle of incidence, angle of reflection? So what we call it as? Angle of refraction, angle of emergence, angle of incidence, angle of reflection. Angle between normal and emergent ray. Yes, your answer is correct, ma. Very good. It's angle of emergence only. So your option is correct. Very good. Keep it up. Now coming to the next one, let us see. This is for your teacher, a monster. Is your a teacher a monster? Because you are answering all the correct answers. So that's why is your teacher a monster? Now just go to the next one. So with this, it's 21,680 points. Oof. So few members are typing very late due to the network issues, I think so. Don't worry, it just happens, right? It's correct answer. B is correct, ma. Now here coming to the next question, that among the following speed of light is high in. So among this following, is it speed of light high in kerosene or diamond or ice or water? So which is the correct answer? So kerosene, diamond, ice, water. To answer this question, you need to know the refractive index of these values, these mediums. Then only you can answer it correctly. So is it kerosene? Is it diamond? Is it ice? Is it water? Yes, your answer is correct. Very good. Very good. So ice. So water, ice, diamond, kerosene low. Ice having the lowest refractive index, therefore it is high. Okay. Yes. So among the following speed of light, ice speed of light is high. Now coming to the next question, that is 28th one. So this 22,580 points. Okay, very good. Now coming to this 28th, at critical angle of incidence, the angle of refraction is, at critical angle of incidence, the angle of refraction is 0 degrees, 45 degrees, 90 degrees, 30 degrees. At critical angle of incidence, the angle of refraction is, so critical angle of incidence దగ్గర angle of refraction ఎంత అవుతుంది? What will be the angle of refraction? 0 degrees, 45 degrees, 90 degrees, 30 degrees. So yes, your guess 90 degrees is correct. Very good. So option C is again correct. Congratulations. Very good. Those who are typing this. So at critical angle of incidence, it grazes between the interface of the two media. Therefore, then it will be 90 degrees only. Right angle, you can see that. That will be 90 degrees. Now coming to the next question. So with this, our score is 23,480 points. Okay, yeah. The ray which is incident on a surface, the ray which is incident on a surface, incident ray, reflected ray, normal, none of these. Sorry, spelling mistake. The ray which is incident on a surface, what we call it as, the ray which is incident on a surface. Yes, very good, very good. Lot of members are typing correct answers. Yes, yeah, definitely your guess is right. Very good. It's incident ray only. It's incident ray only, ma. The ray which is incident on a surface because it is falling on that. So that's why we can call it as an incident ray. Which is bouncing back is reflected ray, which is bending and which is passing through into interface at the medium it passes is nothing but called as refracted ray, means which refracts from a surface, it is nothing but called as refracted ray. Let us see what is the score of us. It's 24,380 points. Very good. 24,380 points for us. Okay, the last question, I think so. Yes, dash is an optical illusion. Dash is an optical illusion? Is it reflection? Is it image or a mirage or none of the above? Which is an optical illusion? So మన కంటికి భ్రమలాగా ఉంటది అనమాట. Already I think a question also we get from this on this. So what is this? Is it reflection? Yes, very good. I'm getting the answers. Yes, very good. A lot of members are typing correct answers only. Yes, definitely your guess mirage is the right answer. Yes, mirage is an optical illusion. Mirage is an optical illusion. So, mirage already we discussed that where we can see water on the road when we look from far distance. But when we go there, we cannot find that water. So, this is nothing but due to total internal reflection. Okay. So, this total internal reflection is main example, means village is an example for the total internal reflection. Yes, okay, let's see what is the score for us. And this is for you, Ibex. You get the next one. And then we are at the top position, that is 25,280 points. Very good. So a lot of members have typed this. I think this score is for you only. Actually, I thought that everyone will be seeing here, but I am not getting here. That's why I just ask you to come in YouTube only. Yes, your option, your guess is right, Mirage. So this points is for all of us, 25,280 points. Now I will post this group link, means this quiz link. Just you can beat, because in explaining I just typed some lately, some answers I typed lately, late. So you can score more than this. Okay. So this ended. We have got 25,280. So now you can, here you can see more quizzes also. Okay, now I will share this. So first out of 24 on quizzes. So this you can share it. You can share through Twitter or you can share it in Facebook also. So I hope you all liked it. If any doubts regarding the answers of this 30 questions, you can ask me. And anybody having any doubts regarding this. So I'm very much happy so that you all are participating very interestingly on this Sunday also. I will be more happy if more members will be participated also. Anyhow, I'm happy those who are interestingly participated, like Bhavita, Harika, Aisha, Jyotika, Sai Lakshmi, Reddy Bhavana, Sneha. Very good. Thanks for each and every one. So I'm planning to conduct this type of quiz every week with your support. So just thanks for your cooperation. I'm expecting the same from you. So you just play this in your free time also. If you want this, you just message me. I will post the link so that you can play it. Okay? Thank you. Once again, congratulations those who have typed correctly their answers. Meet you the next session. Okay, bye.